Hello. In this video we're going to look at continuity as it regards piecewise functions. So when you have a piecewise function similar to the two that we have here on the screen, our function is broken up into pieces. Typically those pieces are polynomial. You might see something that is a rational function, but what is usually the case is that each of those pieces are continuous, and so the only thing that you have to worry about with a piecewise function are the jump points. In this case we've got x is jumping at -2 and at +3, and so we need to see that it meets the three criteria for continuity. The first criteria is that the limit of that function at that point exists. From the left and on the right, it's approaching the same value. The second criteria is that the function is defined at that point. And then the third criteria are that those two numbers are the same. So for this example, we have f of x equals x squared minus 5 if x is less than or equal to -2, and x plus 4 if -2 is less than x is less than or equal to 3, and our function is equal to 2x plus 1 if 3 is less than x. So the only two places, these are all three polynomials, and so the only two places where this function might be discontinuous are at those jump points, at x equal -2 or x equal 3. So let's look. So the limit as x approaches -2 from the left of our function, if we're to the left of -2, that means we're always less than -2, and our function looks like x squared minus 5. So that's going to be -2 squared minus 5, and that -2 squared is 4 minus 5 is -1. The limit as x approaches -2 from the right is equal to, well, if we're just to the right of -2, that means we're getting close to -2, but we're always bigger than -2. That's going to put us in this middle category, and so our function is going to look like x plus 4. So that's -2 plus 4. -2 plus 4 is equal to 2. Well, these two numbers are different. That means that the limit as x approaches -2 for this function does not exist. And that means that f of x is discontinuous at x equals -2. And the reason it's discontinuous is because that function does not exist. All right, let's do the same thing for our other jump point at x equal 3. So if we look at the limit as x approaches 3 from the left for our function, well, if we're to the left of 3, that means we're always less than 3. That's going to put us in this middle category. And so we get 3 plus 4, and we get, that simplifies to 7. And then the limit as x approaches 3 from the right, if we're to the right of 3, that means we're bigger than 3. That's going to put us in this bottom category. And so our function is 2x plus 1. So 2 times our x value of 3 plus 1 is equal to 7. Those are the same number. So we get that the limit as x approaches 3 in general for our function is equal to that common value of 7. So that satisfies the first criteria. The second criteria is our function has to be defined. F of 3, well, if we look at this, if x is less than or equal to 3, we're going to be in the middle category. So that means f of 3 is going to follow the function pattern x plus 4. We're going to evaluate that at 3. And when we plug in x equal 3 into that function, we get 7. That is a finite defined number, and the fact that those two are the same means that it satisfies the last criteria, and that is that our function evaluated at that value is equal to the limit. So that means that our function, piecewise function here, would be continuous at x equal 3. The only discontinuity this function would have would be at x equal negative 2. All right, another type of problem that you'll see often that fits right along with this is find the constant, in this case the constant k, so that this function is defined. Well, that means we need these things to happen. We need the limit to exist, and again, k is a constant here, so kx plus 1 is a polynomial, x cubed minus 2x is a polynomial. So the only place that this piecewise function might not be continuous would be at the jump point here where x is equal to 1. So we need the limit as x approaches 1 from the left to be equal to the limit as x approaches 1 from the right. That's the only way that the limit as x approaches 1 would exist. And so if we're coming from the left, that means we're always less than 1. Our function's going to look like x cubed minus 2x, where our x is equal to 1. So we get 1 cubed minus 2 times 1 is the limit as we approach from the left. If we approach it from the right, that means we're always bigger than 1. We're always in this bottom category. And so we get k times 1 plus 1. And so now we just have a linear equation that we need to solve for k. So 1 cubed is 1, 2 times 1 is 2, k times 1 is k plus 1. And if we subtract 1 from both sides, we do get that k is equal to negative 2. So that is the value of k that would make that piecewise function continuous. So our piecewise function would be x cubed minus 2x if x was less than or equal to 1, and negative 2x plus 1 if x was greater than 1. And then we would see if we checked it and went through the same process that we did for this value at x equal 3 on the previous example, we would get that all three of those criteria would be satisfied. All right, I'll see you guys next time.